In this problem, you have to solve for x. So the problem is 256 raised to the power x is equals to 1 by x. So on the left hand side, you have a exponential function that is a raised to the power x. And on the right hand side, you have a fraction that is 1 by x. So how will you solve? One side exponential, another side fraction. So you have to change one of at least, or you have to remove at least one of. So how will you remove? Let us say if I want to remove this x, how will you remove? The one possibility is you can raise to the power 1 by x both sides. So let us try. So we have 256 raised to the power x, and let us raise a power of 1 by x this side, and I have to also raise on the right hand side. Now this is what, if you remember the rules of exponent, that is if you have a raised to the power m raised to the power n, and this can be written as a raised to the power m times n. So if I use this rule, so this is the rule. Now if I use this rule, I can say this is 256 raised to the power x times 1 by x. So this becomes 1 by x raised to the power 1 by x. Now x cancels out, so you will have 256 is equals to 1 by x raised to the power x. Now see, you have 1 by x here and 1 by x here also, something similar. So what should I do in the next step? Of course, you can think of substitution. So let t is equals to 1 by x. So with this substitution, now I can rewrite my equation. This will become 256 is equals to t raised to the power t. Now let us factorize 256. So 256 can be written as 4 into 4, that is 16, 64 times 4, that is 256, is equals to t raised to the power t, not 6. So this is basically 4 raised to the power 4 is equals to t raised to the power t. Now you see, if you compare the base and the exponent, here t is the base and here 4 is the base. Here again t is the exponent and here 4 is the exponent. So this suggests t is equals to 4 is one solution. So t is equals to 4 is a solution of this equation. Now if I somehow prove that this function does not have any other solution, then my job is done, because we have already found one solution, that is t is equals to 4. So let us consider this function, that is ft is equals to t raised to the power t. We will try to plot this function and we will see that this solution has only one root when right hand side is 4 raised to the power 4. So now let us take log both sides. So we will have log ft is equals to log of t raised to the power t. Now here I will use rule of log, that is log of a raised to the power m. This can be written as m log a. So with this I can write log ft is equals to t log t. Now to plot this graph, or to plot the graph of this function, we need to find where this function is 0, that is critical point, maximum or minimum point. So let us differentiate this function and find f dash t. So if I differentiate both sides, this side we will have log of ft will be 1 by ft, and then differentiation of ft is f dash t and then this side we will have u into v. So we will differentiate. So first we will leave t and we will differentiate log t, that is 1 by t. Then I will leave log t and differentiate t. So differentiation of t is 1. So I can say f dash t by ft, this is equals to 1 plus log t, or we can further rewrite, that is f dash t is equals to ft times 1 plus log t. So this is log t. Now to plot this function, we have to find the critical point, that is point at which f dash is 0. So this means either this term is 0 or this term is 0. Then f dash t will be 0. But ft will not be 0. What is ft? That is t raised to the power t. It will never be 0. So this is a non-zero. So only one possibility, that is 1 plus log t is equals to 0. This means log t is equals to 1, and let us say this log is on the base of e. This means t is equals to e raised to the power minus 1. So this is minus 1 here. That is t is equals to 1 by e. So now we have found the critical point, the point at which you will have maxima or minima. So this is the point at which, that is t is equals to 1 by e. So this is the point at which you will have maxima or minima. So let us try to plot the graph of this function, that is t raised to the power t. So here I will plot this function. So this is my y-axis and this is my x-axis. Now see, the maxima or minima occurs at 1 by e. So this point is 1 by e. Now this function t raised to the power t, if t goes to infinity, so on the x-axis basically you have t-axis. So this is t-axis and this is y is equals to ft. So if t goes infinity, in that case ft will also go to infinity. Now if t tends to 0, what will happen to ft? And this you can find using limit. So limit t tends to 0, t raised to the power t, when t tends to 0, this is equals to 1. And this you can prove using calculus. And t raised to the power t cannot be negative. So this cannot be negative. So this cannot be negative. Now let us find increasiness and decreasiness of this function. So I know ft is equals to, f dash t is equals to ft times 1 plus log t. So now let us say I have t value and here I have f dash t value. So if t, because it cannot be negative, we are not interested in this side of the graph because I cannot have this side. So t is equals to 0. So let us say if t is equals to 0 to 1 by e, because 1 by e is a critical point, what will be the value of f dash t? In this case this will be negative because you will have log of 1 by e and then this number will be negative number and this will be greater than 1. So this is a negative quantity. And if t is greater than equal to 1 by e, then this will be basically a positive quantity. So this means in this region 0 to 1 by e, the function is decreasing. And at t is equals to 1, t is equals to 0, we already showed that this function is 1. So at t equals to 0, this function is somewhere here 1. And then this is decreasing. This means here you will have minima point and then it is increasing. So this function is like this. So this will not be a straight line, something like this. Now the original equation is t raised to the power t is equals to 4 raised to the power 4. So 4 raised to the power 4, that is 256, this will be somewhere here. Or you can say a little bit upper, but this graph is not to the scale. So now see, there is only one solution. So this is the solution that we have, and this solution will correspond to t is equals to 4. So this solution, if you project on the x-axis, this will correspond to t is equals to 4. And there is no other solution because this line is increasing. So we have shown that this equation will have only one root, only one solution, and that solution is 4. T is equals to 4. So substituting backward, if you remember, we have said t is equals to 1 by x. So this means x is equals to 1 by t. So this means x is equals to 1 by 4 is the solution of this equation. So I hope you enjoyed this video, and if you enjoy, please share with your friends, subscribe to channel and like this video. I will see you in the next video. Thank you.